Hey there. I hope you've been enjoying this conference as much as I have. Welcome to my session today on AI on FHIR, how standards can really revolutionize how we use AI and NLP output uh, in healthcare. So, today we're going to talk a little bit first about who I am. Uh, I'm going to give you some insights into why I'm really excited about AI and NLP in healthcare. We'll talk about why standards are going to make a big difference there. And then I'll introduce you a little bit to what some of those standards are, in particular FHIR, which is the new kid on the block. We'll talk about what AI standards could look like in FHIR. And finally, I'll wrap up by showing you actually how I did some work to map Spark NLP healthcare output to FHIR. So first, who am I? My name is Sam Schifman. I'm the chief architect at Diameter Health. I've been doing software for a little over 25 years now in all kinds of different industries, from HR to finance to no code development platforms. And at every stage of the game, I've seen how NLP and AI could really assist computers make a big difference in people's lives. Uh, about 3 years ago, I joined Diameter Health and again saw how it could really have a huge effect on healthcare, which we're going to talk a little bit more about today. But I also spent a lot of time at Diameter Health working on how we were going to transform data from the existing CCDA standard to a new standard called FHIR. And that inspired me to really think about how this connection between NLP and FHIR could really make a difference. So, first, let's talk a little bit about what I see AI as being so important to healthcare. There are really two forces that are really going to come together and collide in healthcare today. One is the fact that in 2034, there will be more people over 65 than under 18 for the first time in this country. This is already true in Japan, and similar estimates are true for much of Europe. We really have to think about what the effect that's going to be. We know that older people generally have more healthcare needs, they see more specialists, and they just have a longer health history, right? At the same time, we're seeing a massive shortage of medical professionals, be they doctors or nurses or whatever you want to talk about. Some of this is due to COVID, where these people were asked to work heroic hours under terrible conditions, and now they're just frankly tired. Uh, some of it has to do with that aging population. That leads to more people retiring. But it also has to do with a fundamental transformation that's happening in our healthcare system, which is it's starting out as really a patient provider centric world to a much more holistic world. Uh, but we're in the middle of that process, and that sort of change is hard. And right now, healthcare professionals are dealing with increased work in less time, with a lot more administrative and documentation responsibilities, which are really hard for them to manage. And so we shouldn't be as surprised to see that a lot of them are burning out. Now, some people think that AI and NLP in particular are going to come along and replace what doctors and nurses do. This is one estimate of how much work the AI will fill in. I think that actually this is looking at the problem from the wrong angle. I think the people who are really going to be affected by this change in healthcare are first the loved ones, right? Generally, as people get older, they face issues with mobility and with mental decline, and generally end up falling on their younger loved ones to help shepherd them through an ever more complex healthcare system, right? Uh, Often these loved ones are actually living geographically different places than the people they're trying to care for, and they're not medical professionals. The other people that this is really going to fall on are the health plans. Now, health plans traditionally have been very reactionary. They get a claim in, they decide to pay it, right? Uh, However, as the costs of healthcare skyrocket and the need for more care comes in, um, they're going to have to get much more proactive, and they're going to have to start really partnering with their members in order to control costs. Now, they're not going to be able to hire enough nurses or doctors to do that, right? So they're going to have to fall back on administrative staff who are, again, not medical professionals, right? So both of these parties are really going to struggle with how to help the patient really get the care they need. So what do we need? Well, I really think we need to start thinking about this as an internet of health. We really need to start thinking about building the connections between the patients, their loved ones, the health plan, the providers, so that they can all partner together to have great outcomes for the patient. And in that process, they're really going to need to think about new streams of data. One of the big examples here is, of course, wearables, right? If the person you're trying to care for is remote, having them have, say, a smartwatch on can make a huge difference, particularly if you have access to that data. But again, that data has to make sense. And this is really where AI comes in, right? It has to be able to help those non-medical professionals make good decisions about when they need to make sure that their loved one has care and what is the right care for them to get. So why do standards matter in all this? Well, there are a number of reasons, but I think the big one that I want to talk about today is the fact that we just don't have a crystal ball, right? We don't know what the power of all this data will be down the road. We have some inkling, and I have guesses, right? But we don't know. Today, what I see is that most AI is used in a purpose-built manner, right? For example, staging of cancer, right? We run NLP in order to try to figure out the staging of the cancer, but the output of that is very custom, and it's built for a single purpose. If we bring that data instead into standards, right, it can be made available for any number of applications down the road. A great example of this is a talk I heard by Katie McCurdy talking about the work she was doing at Pictal Health, where they were trying to help patients visualize their health history in a way that their doctors could see it very quickly when they walked into a specialist or a new doctor's office, right? I think that this could be super powerful if it could be done not based on how she was doing it at this point, which was really long, in-depth interviews with the patient, but instead built off of standard data. And if that data includes the results from NLP and other AI engines, it can just be enriched in a way that it could never have been before. But the beauty of having it in those standards is that Katie McCurdy doesn't need to know anything about AI, right? She just needs to know about the standard data in FHIR. So what is FHIR? FHIR stands for Fast Healthcare Interoperable Resources. And it's the latest step in a long history of standards that have come out of HL7, which is an international standards board for healthcare. Back in, I believe it was the 90s, they built a standard called HL7v2, which was really a point-to-point connection standard. Back in those days, hospitals and labs were still using modems, and the modem would call from the lab to the hospital and send these little tiny messages. They needed to be short. They needed to be, they need not have a lot of extra data in them, and both sides knew what they were communicating about, right? So the structure was fairly custom. This, of course, doesn't lend itself great to interoperability, and so after a time, the CCDA standard was introduced. This brought an entire health record, everything that an EHR knew about a patient at the time that they left an encounter was encapsulated into one large XML document. It was highly structured, so easy to read by a computer. It also had human readable sections to it, but it was big. And in today's world, where we need to communicate quickly to mobile devices, and we're really particularly interested in certain types of data. For example, an emergency room doctor really wants to see allergies and problems. They may want to drill down later into results and things like that, but those are the things that they need to see first and quickly, right? So FHIR was introduced, where we really break up that large CCD into individual tiny resources. And FHIR also adds on top of that, based on RESTful practices from the web, an API or protocol for how to transmit those resources, and also a standard way to expand those resources, which is really good. So this means, though, that FHIR is made up of a bunch of little tiny resources that are all pointing to each other. For example, we have observations, which can be test results or vitals. And then we have conditions, which are problems, right? And those point to a patient record. They also point to the encounter in which they were diagnosed or tested. And they point to a practitioner who did it, so on and so forth. We have all these little tiny resources, which is great, particularly for NLP output, and we'll talk more about that in a moment. But let's just understand quickly what a resource is, right? So a resource has a type, which in this case, in this example here, is an observation, which means it's a result of some sort, right? Something that's been observed about the patient. They always have an ID, a unique ID, just to give them a unique identifier in the world, right? Often they are refined by a code, and in this case also a category. So the category tells us this particular observation is a vital sign. Not every resource will have a category, but most resources will have a code that gives you the information, for example, here, that it's a blood pressure, right? They'll have links, as we talked about, to other resources. And we see here the values, and this is called a value quantity. We'll talk a little bit more about that in a moment. But you see the value with the units and the reference ranges, which are really important to be able to understand what normal should look like. So how would this all play out in NLP or AI, right? So as I look across all the different forms of NLP and AI that I see out there, I see that each one of them is doing really magical things underneath the covers. Each one has great new ways and new ideas of how to get at the information, but what they're trying to get at generally really is pretty standardized. Basically they're looking for entities in the data and then attributes about those entities. So named entity recognition is the best example of this, right? Where we're really looking for particularly entities in the data, like an observation or the definition of a condition, right? Some words that mean that they might have this or they might have that, right? And some attributes like, is it about a family member or is it actually about them, right? And where is it in the text? I think sentiment analysis is a little bit out there, but it still is really about an entity, which is the whole text in this case, and the sentiment is an attribute about it, right? And then clinical inference, which is really about trying to infer what data is missing from the record, right? That is also looking for entities which should have been there and evidence as to why they should have been there. So those are kind of attributes about it, right? So we can model all that with a couple of different resources. These are new resources that I'm proposing to be added to the FHIR standard. The first one is inferred entity, and let's look at a couple of elements from this. First, I mentioned that value X. FHIR has this idea that you can have a value quantity, a value string, a value range, whatever sort of value data type you want. Often in an inferred entity, I've found that this should be in a value string that says the string of the name of the entity that you are identifying, right? Next, we have some attributes about that, and that could be whether the assertion on it as to whether it's about that patient or a negation or about a family member. It can also be the location within the text that we found it, right? And some codes that we might have inferred about that, right? So again, that refining of it down to a code. But the most important one, I think, is really this entity type, right? One of the big frustrations that I've run into working with NLP data is that every named entity recognition has a different lexicon for what it's going to call the entities, the type of the entity that it produces, right? if we can standardize that, that would just go a huge distance to being able to make this data interoperable and usable in many different cases, right? And I have a suggestion for that, which is that, FHIR already gives us a list of entity of resource types, right? They call them resource types. It'll need to be extended a little bit for NLP because it doesn't include things like date, but we can do that in a standard lexicon and therefore really make this data much more interoperable. From that, we really could be able to take these inferred entities and convert them to actual FHIR resources. So if we know that the inferred entity has an entity type of condition, we know we can transform that into a condition resource, right? We have to do this responsibly. We always have to make sure that we're looking at the confidence involved and that we're making it obvious to the user of that condition resource that this was inferred. And so I'm suggesting some changes to the meta tag here to make that obvious to people. Finally, I also think we need an inferred relationship. This is just a resource that points out that two inferred entities have some relationship to each other. So for example, a condition has a relationship to a date, right? So how does this play out in SparkNLP, right? As I said, I did some work to do this mapping for some exercises some experiments that we did internally. So let's look at how that happens, right? Okay, so here we have on the left the output from SparkNLP Healthcare. And on the right, we have what is called a FHIR inferred bundle. So FHIR has this concept of bundle, which is a collection of resources. In this case, I'm only showing two, but there could be many resources in this bundle, right? And because it's a type of inferred, I can say that it's going to consist of a certain set of resources. Now, the first resources here is one that I kind of made up. It's an organization resource to represent the John Snow Labs SparkNLP for healthcare, right? There could be a bunch more information here. Actually, that would say, what models I was using and so on and so forth. But that gives me something that I can reference later. So the first thing we have is we have the entity type, right? In SparkNLP, this was a disease syndrome disorder, which was a condition. As I said, there's a lot of confusion here. These are all the different entity types that I saw in SparkNLP, which I thought mapped to condition. Now, I'm not a doctor or a clinical informaticist, so I could have gotten some of these mappings wrong. But the point is that having this long list on the left here is a little confusing. If we can really have it just say, here's a condition, and then we can use codes to get to the fact that it happens to be a pregnancy condition, right? Confidence is very important. We need to represent confidence always. We need to be clear that data is probabilistic in nature. Here we have some pointers, right? That one is to the organization, so that we know where this data came from. Another is some pointers about or tags about where we got that data, which just helps us know what we were dealing with. So in this case, this was found in a note using NLP. Right? Then we have that value string, right? Here in this case, I'm using value string rather than value quantity because it's just a set of text that the NLP found, which was thyroid disorder. Right? Now we have an attribute here, right? The SparkNLP told us that they thought it was present and what confidence they had in it being present. And so I translate that into an attribute that is about assertion, right? And later we'll see one about the location. And also, we have SparkNLP looking for ICD-10. So in the pipeline that I set up, it looks for ICD-10s to predict what the correct ICD-10 was. And in the inferred entity resource, we have a place to put those codes. So Another thing which you'll see when you see this, the note I was dealing with shortly, was that it did come with a date associated with it. And so I created another inferred entity, which was that date, and then captured the fact that there was a relationship between the two inferred entities. So we're going to look here quickly at a little bit of a recording of a demo that I did, and it's recorded just because I don't want you to have to deal with all the screen switching and everything like that. I'm going to walk you through it. This is a CCD. What you're looking at now is a CCD in a style sheet that's Diameter Health style sheet, and it's for this patient Amelia Pond, who's completely made up. There's no PHI here, right? Amelia has currently 3 problems in her problem list. And now we're going to take a quick look at the clinical note that was recorded. And you'll see in the clinical note, Amelia has thyroid disorder mentioned, right? So let's first just send that clinical note to SparkNLP. And I have a little wrapper that does that transform into an inferred bundle. And you'll see here, now we have the inferred bundle, we have the organization, we have all that information that I talked about before in the example. And I also have the location here within the text and the fact that it's present, right? Okay, so now I have everything running on my system in a program we call K8s. I'm going to upload this document to Diameter Health. So as I upload it, our AI worker is going to extract the notes, and it's going to send them over to SparkNLP, get those results back, and transform them into actual resources, or in this case, entries, right? So now we see that she has 4, including thyroid, and her problem list, right? And we can see that the text that came through was thyroid disorder. The source of that is inferred, and we have the original note it came from and the location within that note. And with that, we can show the actual text with highlighting the evidence of why we inferred this particular problem or condition. So, I hope that you've been able to see that it is definitely possible to build this standard and to do the mapping to the standard. But I also hope that you really have seen and understood that it's super important that we do this, that the power that this can unlock is really unprecedented in healthcare. The ability to use this data for all kinds of purposes down the streams, but also the ability to make sure that we're responsible in the use of that data is just key to solving the problems that are going to be facing healthcare in the next 10 to 20 years, and actually, honestly, even facing healthcare today. Thank you very much for your time. I'm happy to answer any questions that you have. If you want to know more, please reach out to me. Come hit up the Diameter Health website, or you can download the white paper that's linked here. It's also accessible via our blog. If you look for a blog entry on why NLP's AI standards are important, written by our co-founder, John Demore, there'll also be a link to the white paper there. Thank you, and I really hope you enjoy the rest of this conference.